So we have a question that says, at what times on the interval 0.5 seconds to 2.25 seconds is the rate of oil loss the greatest and then the least? So if the function that tells us about the rate of oil loss is R of t. So if we want max and mins of R of t, then we need to use its derivative, right? Because that's how we find max and mins of a function, by looking at the zeros of the derivative. So we're going to do that using our calculator. The other thing we have to wonder about, though, is this asking us about absolute max and min? Whenever you're in a word problem and you're asked to find max and mins, absolute max and mins are likely going to come into play. And the way you know is by asking yourself, could the value 0.5 be the answer for when the rate is the greatest or least? And could 2.25 potentially be the answer? And yes, they could, especially since they indicated a closed interval here. So yes, it is. And we're going to do a candidates test. And what we're going to need for the candidates test is we're going to need to get the values of the two endpoints, and we're going to have to get the y values of any critical numbers. And we'll have to find those critical numbers as we go. I'm going to show you how to do this using your calculator. So in my calculator, in y1, I went ahead and put the R of t, I guess it was R of t function. I went ahead and put that in there. And real quick, before I do anything else, I'm going to adjust my window because when you're dealing with trig functions, because they're periodic, it could take a very long time for them to graph sometimes. So I'm going to go to the window. Yeah, I'll make x at negative 0.5. I don't need to go further than 3. My y min, you can trust me on this one for this problem. Negative 1.5 is fine, and 8 is fine there. Okay, so I have my r already here. I'm going to graph it. And when you're looking at a graph, you can find the value of a specific point, and you should not use the trace function. What you should do instead is use the value function. So I'm going to hit second calc, and I'm going to hit option 1, which is the value. So x equals, and if I remember, 0.5 was the left endpoint. So I'm going to hit 0.5, enter, and I get a y value of 3.66981. So I'm going to go ahead and write that on my paper. So I have that 3.669, and I think that's milliliters per second. And let's go back here. The other endpoint was 2.25. So now I'm going to do this again, second calc, option 1. And I'm going to hit 2.25. And I get this value here, 5.0224. Or 5.022 is enough. So I have my endpoints handled now. Now I need to see if there are any critical numbers. The best way to find critical numbers right now is to graph the derivative. If I graph the derivative and I find the zeros, I'll find the critical numbers. So I am going to use a little bit of a shortcut here. Instead of calculating this derivative, I can actually use the derivative that's built into the calculator. And to find that, I use math, and then option 8, the nderiv, or just derivative. So I hit math 8, and then I fill in my variables. So there's my x. From my function, I'm going to use y1, and so I go here to the F4 to get my y variables. I select y1 and hit enter. So this is saying get me the derivative of y1. And then we're not evaluating at a specific point. So what you enter here is x. And so now I'm going to also get a graph of this. So where these zeros appear, This one would be a maximum of R of t, because the derivative is changing from positive to negative. And then this one would be a minimum of R of t. So we're going to find those by finding the zeros of the derivative. So again, I use that calculate, which is above trace. And I'm going to use option 2 for zeros. And then the first thing is, oh no, the cursor is on the wrong function. So all I have to do is hit over here the down arrow, and the cursor will jump to the other function. And it's asking me, hey, are you on the left of the 0? Indeed, I am on the left of the 0, so I hit enter. Now it wants me to move along until I'm at the right of the 0. And the way you can tell is when the y turns to negative. Right, so now I must be on the right. And I hit enter. And it says, do you want me to guess? I hit enter. And here we go. I get an x value right here. And I'm going to write that down really quick, but I'm also going to store it. Jump out of this screen really quick. And I'm going to hit X. And then I'm going to do store alpha A. So what just happened is I stored the answer that I just got on the graph in alpha A, so I can use it again. Now I'm going to find the other 0, same way. Option 2. Again, I've got to use this down arrow to get my cursor. It's on the wrong 0 now, yes? So I'm just going to scoot along. Am I to the left of this 0? Yes, I am. I can tell because the y is negative. Then I'm going to pop over till I get to the right of it. There, my y is positive. And there's my value. I'm going to write that down on my paper because I'm going to need it. And I'm also going to store it in alpha A. So I get out of the screen. I hit X and enter. That gives me the value that was just found on the graph. And then I hit store alpha B and enter. So now, I mean, I can type those values in here because I wrote them down. This was, there's a critical number at 1.315, and there's a critical number at 1.958, and they're both within the given interval. So I need to evaluate R of t on those two values. And I can do that in either screen. I can do it here by doing alpha parentheses, and then I can hit alpha A. And it'll evaluate it for me. And I also can do it, I want to show you this. I can also do it on my graph. So I'm going to do second value and x equals, and I'm just going to hit alpha A, enter. And, you know, I want to make sure it's on the right graph. It is on the y1 graph, and there's my value, 1.315. Oops, I'm sorry, my y value, 5.0765. And I'm writing that down. And then I'm going to do that same thing again. I'm going to get the value, enter. X equals alpha B, enter. And make sure your cursor is on the correct graph. And then here I see the value for that critical number. It's 4.897. Remember, I only need 3 decimal places. So we come over here and enter those two. This one was 5.076. This one was 4.897. So I did my candidates test. I showed the 2 endpoints in the evaluation. I found the critical numbers and evaluated them in R of t. And now I need to know which one of these R of t values is the greatest. And that is right here. So I'm going to say at time equals 1.315 seconds, the rate of oil loss is the greatest. and at t equals, looks like it's the endpoint, right? Yes, 0.5 seconds, the rate of oil loss is the least. Okay, that was a pretty involved problem as far as calculator work goes, but I wanted to show you kind of how to navigate something like that on your calculator. And what would be great if you have time is to do this problem again, clear out everything in your calculator, and see if you can run all those steps again and be comfortable with how that functions.